Oh yeah. Hello again. So welcome to Structural Analysis and Design Made Fun and Easy. This is this is part 4 of the series of videos on the reinforced concrete brace short column with square pad foundation designed to BS8110 UK concrete. Just a really simple case, very simple pad. Just to get started. Please like the video and subscribe to the channel. Please donate if you can to let me make more videos like this. So, in the other videos, this is part of a playlist. But in the other videos, we worked out the loads, ultimate loadings on the column, and ultimate loadings on the column, and the bearing pressure under the pad foundation. And now we worked out the shear stress along a line from 1.5D from the face of the column. So all that is in the previous videos. So in this video, this is just the last one. It says part D of the question: determine the punch and shear stress in the base at a perimeter of 1.5 times the tensile steel effective depth from the face of the column. So number 1, as previously mentioned, it does not seem to have a column dimension, so we just are going to assume for now that it's 300 millimeters times 300 millimeters column. First thing to do is to determine the punch and shear perimeter at 1.5D from the column face. So basically, it's a little bit dark. I really need the flash on, but it's going to reflect off the screen. So the first thing to do is the base. This isn't drawn to scale, but let's say the base is this big. Here's the column in the darker. That's say 300 by 300, and it says determine the punch and shear at a distance of 1.5 times D around the perimeter of the column. So first thing to do is to determine the punch and shear at 1.5D from the face. So 1.5D is equal to 1.5 times 340 millimeters, and that is equal to 140 plus 170 equals 510. So that distance from here to here is 510 on each side. So it's 510, 300, 510. So what the length of one side of the punch and shear perimeter at 1.5D from the face of the column is equal to 510 plus 300 plus 510. That's equal to 1320 millimeters. So this from here to here is 1320 millimeters. That's 510 times 2, 1020 plus 300, 1320. So the total shear perimeter. Oh, so that was the next thing to do. The total shear perimeter, UO. That's equal to 1320 times 4, because it's 1, 2, 3, 4 times round 1320 here times 2 times 3 times 4. That equals to 5280 millimeters. That's the shear perimeter at 1.5D from the column face shown in the red dot dash here. You can see that distance there is 1.5D. 1.5 times 340 is 510. So all of those 4 dimensions are 510. So that means that distance, the punch and shear perimeter for 1.5 effective depth is 5280 millimeters. So now we can determine the punch and shear value. Now we can the punch and shear stress at 1.5 times D. I've done another diagram here, but the value, you have to take the whole column load ultimate, which is 1040. VP is equal to 1040 divided by the shear perimeter times the effective depth. I haven't put it there, but it's basically equal to N VP shear punching stress is equal to N ultimate divided by the UO, which is the total shear perimeter, times the effective depth. So that's 1040, which is N ultimate 1040 actual load on the column, the punch and shear perimeter is 5280, which we just worked out above. Effective depth is 340. So therefore VP punch and shear stress is 1040. Oh, that's kilonewtons, by the way, so it's times 1000. So cancel out the 2 1000, so 1040 divided by 5.280 times 340, and that gives you 0.579 newtons per millimeter squared. So that's really quite easy. So on the diagram, I just done like here, that arrow shows 1.5D. This is not to scale as well, by the way. This is 1.5 times D from here to here. That's so when I drew that diagram, that was like a view. That red line is a view from the top, looking from the top. But, and I drew those red lines in this at 1.5D from the column, and I done like a little 3D diagram. That red line around here, that's a shear perimeter at 1.5D from column face shown in red dot dash isometric 3. So the columns here, sorry, the column's not drawn very well, but that's in the middle. Then this shear perimeter here, and assume now that the column dimensions are 300 by 300 millimeters as above. So that's the column. This is the ultimate load, 1040. Here's the shear perimeter along those lines. This is a cross section, so it's only in 2 dimensions, but this is like the typical failure plane might look something like that. It's going to crack sort of in a diagonal, almost 45 degrees. So the column would just punch away from the base, basically with shear across here. So the stress underneath the base here will be massive because we worked out before it should be the bearing pressure spread out over the whole thing would be 210 kilonewtons per meter squared, but obviously it would be if the base was too weak, then this stress would underneath the footing would be too high, and then this could punch through shear failure along this plane across this plane. So that red line would be just like this section. It would be overbearing on the ground underneath, and this bit would just collapse. So you'd have yeah, that's the idealized shear pattern. I'm not drawing it perfect, but it's just to show you. So the shear punch and shear stress at 1.5 times D is equal to 0.579 newtons per millimeter squared. So that really concludes this entire question. That's a series of 4 videos. This really got me more interested into doing punch and shear design. So because this is for a pad foundation, but there's also lots of interesting punch and shear failure for slabs and flat slabs. Basically, that's the main thing. So I'm going to start doing some more videos on this. Please see more of my other videos for more information on this subject of punch and shear. Yeah, thanks for watching. Please subscribe. Please like the video. Please donate if you can to let me do some more videos of this. But hopefully you found this series of videos useful, just to get started. Because obviously more complicated situations will be where the column has moments on it, where the column has eccentric, where the column, the pad will be more complicated design as well, where there's moments on the column because you'll have overturning of the base and things like that. But this series of videos was just to get started. It's just very simple. Thanks for watching.